Welcome. Today we are again talking about finding the area of regular polygons. But this time we're going to be given even less information than in the previous video, and we're going to have to use trigonometry. So first, let's review. The first time that we talked about finding the area of regular polygons, we were given a side length and an apothem length, and we used this formula, where S is the side, A, the little a, is the apothem, and N is the number of sides that the shape has. But what if you're only given the apothem? We have an apothem of 6 here, and that's all. We know it's pentagon, and we don't have any other information. But we can still find the area. We'll still use that area of the little triangles idea, but there's going to be some work to do first. So first, let's draw in a radius so that we can see the right triangles. We've been working with these triangles in here. Let's go ahead and draw that in. So there's our right triangle. And we know one of the sides. If we knew a second side of this right triangle, we could use Pythagorean theorem. And we did that in our previous video. If you haven't watched that, here's a link to it up at the top. But we don't have another side. We don't have a second one, so we can't use Pythagorean theorem to find the third. What we're going to have to do is use trigonometry. But if you remember, for trigonometry, we need to compare the side with an angle. So really, our next step is to find one of the angles inside this triangle. So think about the entire shape with me. If we rotate all the way around the center, that takes 360 degrees. That's the full rotation. But we just need the little angle up at the top of the triangle. So we have to think about how many of those triangles there would be. Let's go ahead and split this up. It is a regular polygon, so if we add in all of these radii and all of these apothems, we make congruent triangles all the way around. There are 10 of these triangles. 5 sides, 2 of those triangles on each side, so there are 10. If we take the full 360 degrees and divide it by 10, that means 36. So the angle at the center tip of each of those tiny triangles is 36 degrees. So when we focus on this right triangle now, we know the one side is 6. We know the angle up at the top is 36. And really, we want to know what the base is. If we find that base, then we can find the area of this triangle, and that's kind of the goal. That's the next step to getting us back to the pentagon. So thinking back to trigonometry, we have our reference angle up at the top, that's 36. The side we're looking for is the opposite side. The side they gave us is the adjacent side, so we can use tangent. We'll fill in the things we know, 36 degrees for theta, x for our opposite side, and 6 for the adjacent, and then we'll just work on solving this. I'm going to multiply both sides by 6 so that we cancel out the fraction on the right. And then we'll just go to the calculator and take 6 times the tangent of 36 degrees. Make sure your calculator is in degrees mode, but you should get 4.359 for x. So that is our opposite side, 4.359. Now this is not your final answer. We are quite far from our final answer right now. But what we can do now that we have this measurement is take it back to the pentagon. So there's our 4.359. The other side, the other half of that side of the pentagon is also 4.359. So if we wanted to know the entire length of a side, we add those together and we get 8.718. But now we have everything we need to use our fancy area of a regular polygon formula. We know this is a 5-sided shape, so we know n is 5. We just found that s equals 8.718. So we'll throw that in there. And then the apothem we already knew was 6. So we'll start to simplify this out. Multiply all 3 of those together, we get 130.77. So of course then for our final answer, we're going to round to the nearest tenth and throw our square units on there. So if you're given just the apothem, you can use some trigonometry and find the entire area. Here's another example. We're not given the apothem this time. We're just given a side length. Our heptagon looks very blank right now. There's nothing in the middle. But our basic strategy will be the same. So the first step is going to be to find your right triangle. In this case, we're going to need to draw in the apothem and the radius, but then Ta-da, there's our right triangle. Now we need to determine how the information that we were given fits with our triangle. Obviously, I didn't draw my triangle over where the 7 was, but if that side of the heptagon is 7, all of the sides are 7. My right triangle only uses half of the side though, so the base of my right triangle is 3.5. The next step would be to find that central angle, that little angle up at the top of our triangle. So to do that, you take the full 360 and divide it by 2 times however many sides your shape has. Because remember, each side is going to have 2 of these little triangles on it. So we'll take 360 and divide it by 14, because we're working with a 7-sided shape. And we get 25.7 for this specific central angle. Once you have your angle and one of your sides, then we can use trigonometry to find the piece that you need, or pieces that you need. We only need one more piece. We don't actually care how large the radius is. The radius isn't going to help us with our area of a polygon formula. What we need is the apothem. So when we're looking at our little triangle here, we've got the opposite side is the 3.5. The adjacent side is the A, so we're going to use tangent again. We'll fill in our numbers. So tangent of 25.7 equals 3.5 over A, 3.5 being the opposite side, A being the adjacent. Now I'm going to go ahead and use my calculator to get the decimal approximation for tangent of 25.7 degrees. I find some people find it easier to work with the tangent function itself, just type it all into their calculator later. But this is one of those that I've noticed a lot of folks like to have the decimal. It just makes it easier to understand the algebra that you're doing to find A. So tangent of 25.7 degrees is approximately 0.481267. So we'll just substitute that in. Now, the A that we're looking for is in the denominator right now. So I'm going to multiply both sides by A. On the right-hand side, that will cancel out our A's because we're dividing by A and multiplying by A. So we'll rewrite this. And now since it's A times our decimal number on the left, we'll divide by that decimal number on both sides to get A all by itself. And we get A is 7.27246. Now I'm not going to round this number yet because this is still very far from my final answer. We have a lot more we need to do with this number. So I'm just going to put it back into our heptagon so I know where everything is. But now that we have A, that's our apothem length. We were already given the fact that S was 7, so we have everything now that we need for our area of a regular polygon formula. We know this was a 7-sided shape, so N equals 7. S we were given is also 7, and then the apothem length is 7.27, with, of course, as many decimals as you can keep since we weren't done yet. You never want to round your answer until the very, very end. So I went ahead and multiplied the first 7 by the 1/2, got 3.5, and then we'll multiply all 3 of these together and we'll get 178.1753, which once we round it to the nearest tenth will be 178.2 square units. And that's our area. So even if you're given very little information about your polygon, just one measurement, a side, an apothem, a radius, you only need one, as long as you can remember a little bit of trigonometry to get back to that right triangle. So thank you very much for joining me today, and I will see you next time.